Okay, we've got two presentations from this work package 1. And the first one was intending to give you the overall view of the database. And the second one was intended to give you an example of how data was collected for one country, Italy. So we will switch. I'm sorry for that. Thank you for stepping in, and sorry for the inconvenience with this second presentation.
So, good morning, everybody. I am Erika Barison from OGS. As Arnaud said before, we are included in this project as third parties, as a member of a CO2 network. In this presentation, I give you some example on how we perform our acquisition. Then I show you some example of storage units and traps identified for Italy, and then the final remarks. So the main target, of course, as everybody knows, is to identify suitable porous media for where to store hydrogen, both in saline aquifers and depleted hydrocarbon fields. Some of the criteria are, of course, to have a idoneous capital reservoir system. The minimum depth for the reservoir has been identified within the project at a minimum of 500 meters. Also, if there are some storage units or reservoir also in a shallower depth, but for Italy we kept this minimum depth. The reservoir then has to have an adequate thickness at least of 30 meters, and a reservoir stand with in a range of from 0.3 to 60 square kilometers. Also, we have to consider some other aspects, such as, for example, the presence of seismogenetic sources. And Italy is a very seismic area, so we have to keep in mind when we choose our areas if there are not seismogenic sources in the nearby. For Italy, we consider the database from National Institute of Geophysics and Volcanology, where are collected the seismogenic source that generated earthquake with a magnitude bigger than 5.5. And then, of course, as offer all the Hystories partners, all the data should be free and publicly available. How we perform with our research? We started from with a review of a previous project on CO2 storage. The project, two main projects are ISMA project and CO2 Stop project, that consider the possibility of storing CO2 in underground Europe. And also we have two studies performed inside OGS about the identification of possible reservoir in deep saline aquifers, both in carbonate and interregional rocks. Then, starting from these saline aquifers, the deep ones, we analyze some well-log stratigraphies to identify potential shallower aquifer. Since, as said, for hydrogen, the minimum depth is 500 meters, while for CO2, the minimum depth is 800 meters. So we have to fill this gap. These stratigraphy are taken from the DEPI database. The DEPI database is an Italian database where are collected information from depleted borehole or a sterile borehole. In this database, we have also some technical reports and seismic lines, since they were taken from the oil company that did the survey for hydrocarbon exploration. Here an example of the two stratigraphy. One is in Emilia, in Po Plain. This is well Montalbano 21, sorry. And the reservoir is the one in green. We have a shallower reservoir from 600 to 1 kilometers depth. And then another well, for example, is offshore Sicily, here. With a red point, I hope you can see, you can see it. And in this well, we have a double reservoir, one from about 500 meters to 60, maybe 700 meters, and one deeper in the Paxton around 1 kilometer's depth. Then we also consider the depleted hydrocarbon fields to implement the information for hydrocarbon fields, but some of them are already collected from CO2 Stop and the EastMat project, but this depleted hydrocarbon fields in particular are the ones that are now used as natural storage sites, especially methane, but could be considered for a future change of destination for hydrogen storage. And this information are publicly available at the site of Environmental Minister and Energy Security. And because in Italy, when an oil company, gas company wants to perform a survey, have to give to the minister all the information that they collect. So this information are publicly available at this website. Here, just a brief summary of the main sources we used. So the VDAP database, the Italian Ministry of the Environment and Energy Security, and we also have some information from oil company, gas storage company. In particular, we have Edison Stoccaggio, Snam, Italgas Storage, for example, that also they give information to the government, but also publish some useful information in their website, such as the number of drilled wells, the area, the volume extracted, and so on. So we use information to fill the database. And then concerning the operational data, such as working gas, injection, withdrawal, we use a website that has been already cited, the Gas Infrastructure Europe, that collect this kind of information. All these websites are regularly updated, so you can find year by year new information. Here, the database, it will appear the Hystories database for Italy. We have here in the number of formation are a wider area where we identified. Then inside this formation, we identify 66 storage units, and then even more in detail, 26 traps. This area changed the information, moved to a wider zoom, to a lower to a bigger detail with the traps. Then in this database, just by clicking, this is a screenshot, but just by clicking on the name, you have all information about geographical and geological position. You have information about the lithology, the depth, for example, the permeability, porosity, and so on. And also you have information, especially for the traps, about the working gas, the volume available, and so on. So just to summarize, the storage units that are the bigger number of reservoirs we find out. We have 13 shallow aquifers, that the one in green, a very small area, that we identify, as I said before, by considering the stratigraphy. And we consider shallow aquifer when at least 2 wells have similar conditions in terms of stratigraphy and age of lithology. Then, taken from the previous studies, we have 14 deep carbonate aquifers, 13 heterogeneous aquifers, and then 26 hydrocarbon fields. This area are both onshore and onshore. In particular, the aquifer present very suitable volumes offshore in Adriatic Sea and offshore Sicily. The 26 identified traps, as said, are inside the depleted hydrocarbon fields. This because these depleted hydrocarbon fields have a very specific description of this area, because we were used by oil companies, so we have a lot of information, such as, of course, depth, lithology, but also we have information about the technical steps, so working gas, volume available, so we could identify the traps that are the area where you can storage of the hydrogen or the gas in general. In detail, let's see some area, northern Italy. Here you can see that we have a good coverage. Poplane is one of the most investigated area in terms of hydrocarbon exploration, so we have a lot of information also concerning the depleted hydrocarbon fields. We identify also some aquifers, both deep and shallower, so we could have some also multi-layer reservoir system. In detail, let's see this area with a red circle in northern Italy, in particular the white one, that has been defined within Hystories project and also a master thesis run by a student in OGS. In this area, that also has been published in a paper, we started our research by examining all the stratigraphy available at the DP database. And there are 17 boreholes. And among these, we identify 5 boreholes that show a reservoir in green that have the same lithology and the same age. So we can find out a correlation and consider this reservoir as a unique reservoir. Then, in addition, for this stratigraphy, there were also some sonic logs or resistivity logs. It depends on what was available. But we calculated porosity. So for this area, we also have information about the porosity. And then in the paper, you can also find some an estimation, thanks to Jan Legalo, of a volume storable. Moving to central Italy, we have a good, also good opportunity for storage side offshore. We have a very large volume of offshore aquifers, deep ones especially, but also few depleted hydrocarbon fields that could be considered for storage. Moving to south, we have again 2 big offshore deep aquifers in Adriatic Sea and offshore Sicily, but also we have smaller deep aquifer and shallow aquifers onshore, in particular here in Basilicata on the Ionian Sea. You can see that there are also, it's hidden, but there is also depleted hydrocarbon fields, since Basilicata is another area that has been investigated, is still investigated for hydrocarbon and gas exploration. Then, concerning the 26 traps, again thanks to Jan, we were able to estimate also the static volume, and for Italy we have a total volume of 69.2 hydrogen static volume available. But for this, all this formula and stuff, I think that Jan could be explained better in his presentation, better than what can I do. So just to resume what I said, in Italy we have a good number of suitable conditions for storage units in aquifer, both onshore and offshore. And also concerning the depleted hydrocarbon fields, we have a very useful area, because, as I said, this area have been deeply investigated, so we have a lot of information about this area, and that could be for sure used for hydrogen storage. Even they are now used for natural gas storage, but in the perspective of larger development of hydrogen, this storage site could be moved to this kind of storage. I want to highlight that our study is by now from a geological stratigraphical point of view, because as you saw, you identify a large number of area. So to perform, to go to the next step, so to identify in more detail and to give some number and some reliable information, we have to first choose the more promising area and then investigate in detail this area. Here, the 2 papers we published. The first one is on the Treviso area, the detail area, and then the other one is on the general insight into underground storage in Italy. Here will be some references that I use, and again, thanks to all the partners, and thank you to you. If there are questions, I'm here. Thank you.